Hey guys, in this video I'll talk about volumes of revolution. Specifically, we'll use the disk method to find the volume of revolution around the x-axis. Now let's say we're given this function, f of x. If we rotate it or revolve it around the x-axis, we see this figure. It looks almost like an acorn, it's 3D, and our goal is to find the volume of this. Now the disk method divides this figure into infinitely many disks. I drew 4 here, but with the disk method, there are infinitely many between A and B. Now if we zoom one of the disks up, we can see that it's really just a cylinder. And the radius is f of x because it's its distance from the graph to the x-axis. And the height of the cylinder is dx, which is just a very small increment of x, because there are infinitely many between A and B. Now we know that the volume of a cylinder is pi r squared times the height. So if we plug in these values, we see pi times f of x squared times dx, because f of x is r and dx is h. Now this section here is just for one of the disks. And there are infinitely many between A and B, and we want to sum them all up. So we find the integral from A to B. Now we can take the pi out of the integral since it's just a constant. So we see that the volume is pi times the integral from A to B of f of x squared dx. Let's look at this example. We want to find the volume of revolution around the x-axis of f of x, which is the square root of x, from 0 to 9. From the previous slide, we developed this to find the volume. Now we simply plug in the values, and we see pi times the integral from 0 to 9, the square root of x squared dx. And when we evaluate it, we get 40.5 pi, which is the volume when you revolve this function around the x-axis.